Hey everyone, and welcome to today's webinar, Waters Corporation Technology Solutions for Scientific Challenges. We're just waiting for other participants to join, and we will begin in a couple of minutes' time. So we'll just wait for everyone to join the webinar. So I can see the participant numbers going up, which is great. So for everyone that has just joined, welcome to today's webinar, Waters Corporation Technology Solutions for Scientific Challenges. I'll wait sort of 30 more seconds and then we'll crack on with today's webinar. Still see the numbers going up, which is perfect. Cool, so let's get started. Hello everyone, and welcome to today's session. My name is Ellis Wadsworth, and I'm Senior Talent Acquisition Manager here at HackerJob. And today I'm going to be the moderator of the Waters Corporation Technology Solutions for Scientific Challenges event. Today, we're going to meet amazing experts from Waters Corporation and get to know what technology stands behind science. So, Waters Corporation is the world's leading specialty measurement company focused on improving human health and well-being through the application of high-value analytical technologies and industry-leading scientific expertise. During the webinar, we're going to talk about behavior-driven development with science and improving the developer feedback loop when developing against AWS Cloud. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the Q&A box in your Zoom control panel. I'll bring them up during the presentation, and we'll also have time at the end for a bit of a Q&A as well, so get your questions in. Without further ado, I'd like to introduce today's presenters. We have Chris Preston, Principal Software Tech Lead, Michael James, Technical Lead on the Cloud Platform, and Nick Bird, Senior Talent Acquisition Specialist. So Chris, I'd like to hand it over to you.
Thank you. Hi, hello everybody. So yeah, my name's Chris. That slide that's on the screen there is a sort of a summary slide about Waters. The thing that I work on is the middle picture with the person looking at their screen with some software running. That software is the thing that I work on. So as Ellis said, my job title is Principal Software Tech Lead. I'm going to talk about behavior-driven development with science. So in a nutshell, what I'm talking about is, as a software engineer, which is what I'm trained as, how do I work with scientists to deliver scientific solutions that work for our customers? So just briefly to describe what I work on an application called Waters Connect Confirm Sequence. Our users are scientists who are trying to verify a nucleotide sequence, which basically means an RNA or a DNA sequence, and they're trying to do things like invent new treatments, and they need to verify that what they've made is what they wanted to make. There's a little screenshot at the bottom there of what the software looks like, but it's a web front end talking to a .NET back end, all running on a shared platform that Waters have called Waters Connect. And in contrast with what Michael is going to talk about, the application that I work on is what's called on-premise. So in other words, it's kind of like a traditional desktop application that you install on your own computers. It's not running the cloud. So when Michael talks about the cloud stuff afterwards, that'll be a bit different than what I'm going to talk about. But Waters do both of those things. So that's, in a nutshell, that's what I work on. That I'm tech lead on that project. And I'm going to talk about behavior-driven development and how we use it. So I'll just start off by talking about what is behavior-driven development. Some people will have heard of it, no doubt. There's a person called Dan North who is often credited as the inventor of BDD, and he has 2 quotes describing it that I think show the contrast in how it's progressed. So in 2009, when it was first starting, there was a very complicated quote. BDD is a 2nd generation outside-in pull-based blah, 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 blah. But by 2013, he had refined his marketing techniques a bit, I guess, and he started describing it as it's using examples to talk through how an application behaves and having conversations about those examples. So for me, that's the key part. They're the 2 key things. It's using examples and having conversations. And if you're interested in knowing more about the subject, there's a book by Gojko Adzik, which I quite like, called Specification by Example, which is one of the classic texts in this area, but it talks about, more detail about why these are good things. But for me, the main reason that I find them helpful is I am not a scientist, but I need to collaborate with scientists to do my job. So how can I talk to those people, and how can we understand each other's needs? I don't have the kind of degrees and PhDs and doctorates that they have. So how can I understand what it is that they need? And if we can do that by writing examples, using their terminology, but defined in a way that the computer understands, then that is basically what we're trying to achieve. So I will show some examples later on that are example tests that use the scientific words, but are implemented as automated tests. So it provides a sort of a common language to talk to scientists on. They can read the test and understand that it does what they need scientifically. And because it's an automated test, the implementation proves that the computer is doing what it needs to do to deliver that feature. So one of the key things is that there's a phrase, ubiquitous language, it comes out of the world of domain-driven design. But one of the things that I do with my colleagues is we work to define domain terms such as peptide, nucleotide, sequence. These are all science words that I, as a software engineer, don't know what they mean. But I work with colleagues to try to define what those things are in a way that they agree with and I agree with, and the computer has an implementation or a meaning for. And once we've picked some terms, we make sure that we use them consistently in code and in tests and in documentation as well. So for example, one of the things that we do in our software is we detect something that we refer to as peaks. So what does a peak mean in our context? We define that in our documentation. We use the name in code and we refer to that name in tests, and everybody understands consistently what it means. And it's incredibly useful for aligning my thinking as an engineer with the business domain and the user's thinking. Again, if you want to read more about this topic, there's a book that I'm currently reading called Learning Domain-Driven Design, which I recommend. I'm enjoying it. I would recommend that you look that up if you want to know more about this topic. So what tools do we use to do this? It's very common that behavior-driven development is implemented using a language called Gherkin. And Gherkin it's basically a domain-specific language for specifications. So there's a way of writing tests that can be implemented by the computer using this sort of structured format. So the way that it works is you say, given some preconditions, when some event occurs or some action is taken, then the expected outcomes are found or happen. So given, when, then are words that have meaning in the Gherkin syntax, and they specifically mean set up your preconditions, define what the actions are and carry them out, and then define what the post conditions need to be, define what the assertions are basically at that point. So we use Gherkin as the language for describing these examples that we write with the scientists. And that's implemented for us in my project, implemented using a tool called SpecFlow, which is a free open source behavior-driven development framework for .NET. In other languages, there's often a tool called Cucumber that exists. I've used Cucumber in Ruby before, and there are Cucumber tools for JavaScript and various other things. It just happens that in the .NET world, the most common tool that I know is SpecFlow, and that's the one that we use. But Gherkin can be implemented implementations exist in many different languages. One of the other tools that we use a lot is the type system. So this is the type system in the languages that we program in. We use typed languages. We use C# for our backend, the .NET backend. We use TypeScript for the front end code as well, rather than JavaScript. I have found in my career that static typing is helpful for building complex systems because you can enforce semantics using the type system. There are certain types of error that you can't make because of the type system. It won't let you make certain types of mistake, and there could be other ways of doing that. I know some people advocate using tests to prove that certain things can't happen, and that's perfectly fine, but personally I like using the type system, and that's what we try to do. So we use types as an important tool to represent the domain concepts in our code. So some of those words that I mentioned earlier, like peptide, nucleotide, peak, those you will see in our code. And the code, when you read code, it reads like some business logic, like a domain, like somebody from the domain could understand it. So an example of one of those tests, this is a kind of a basic test, a basic example of what they look like. So this says scenario, which is basically, that means the start of a test. The user processes some data, so you would have a description there. And then this test says, given that the user loads the data set, my sample, whatever, and chooses sensitivity level 4, noise removal factor 20, when the data is processed, then the following peptides are identified, and there's a table of which peptides should be found. So you can see in this test some examples of the things that I was talking about. It's written as if anybody can read it. A user could read that. A scientist can read what that means. We will have defined what sensitivity level means, what noise removal factor means. They'll be in our documentation as to how they're defined. They'll probably exist in the code with those names. Peptides, similarly, that's a defined thing. We know what that means. And so this is kind of the basic structure of what one of our tests looks like. But the problem with this test, as it stands at the moment, is it's not specific enough, because to do good science, it's not sufficient to just find the right things. You need to find them with the right amount of error as well. So you need to be confident that you've found them. So we do various things to measure confidence, but we can do things like writing a test like this, which is the same sort of test basically, but it's extended. So this one says the user performs system validation. Given that the user loads the data set validation set 3, so there we're loading a specific data set that is designed to allow us to validate the results. Chooses sensitivity level 4, noise removal factor 20. When the data is processed, then the peptides are identified and match their gold standard measurements. So if I was in my editor and I click on that line, then the peptides are identified, and I hit F12 as I have in my editor, or it might be a different keyboard shortcut in yours, but I go to definition, that's effectively a function call, that line. That's calling a function that describes what behavior that step, as it's called, captures. So you would see code in there for checking peptide identification and for matching numbers against those additional columns. And those additional columns are defining the sort of the gold standard that we must meet. And our customers are often working in a regulated environment where they have to meet certain standards defined by law. And so our tests we have to have tests that prove that we are meeting those validation standards. And so this is typical of a kind of test that we might have to ensure that. And this will run automatically on every build and tell us whether we've, accidentally broken the software, or if we deliberately make a change that shouldn't change results, then this test will tell us if that's the case or not. This test should still pass even when we make intentional changes, because this is the scientific definition of what a valid system will do. So these kind of validation tests are very important to us. We can go one level further, and we also have tests that are more detailed again, and we are designed for catching accidental problems. So say, for example, we update to a new version of .NET, or we get a new version of a third-party library that we use, and we want to make sure that nothing has changed that we didn't expect, no accidental or unintended changes. We can have a test like this that's more precise. So this is it's not measuring to the scientific standard, it's measuring to greater detail, and it's measuring to a level of detail that if anything changed unintentionally, this test would fail. So we could have a situation where this fails and the previous test passes, and that gives us the information that it's some kind of accidental, unintended change. We didn't expect it to fail. So we can use these different levels of test to kind of give us different information about what's going on. But you can take that too far sometimes as well. What we want is to have stable, reliable tests. So I could write a test like this, which would be the user processes some data with unrealistic expectations. The following peptides are measured with perfect precision. And you look at the amount of decimal places there, the number of significant figures, and they're right at the limit of what computers can represent in floating point numbers. And so that kind of test is very likely to fail if you just run it on a different PC, for example, with a different CPU, it could fail, or against a different version of something inconsequential could cause that to change. Debug build versus release build could cause that to change, for example. So this would really be too sensitive for our purposes. So what we don't want is tests that are failing because of unhelpful reasons. So we have to try and strike a balance in terms of how much precision we go to. We want to have tests that verify the scientific precision, and also tests that help us catch accidental changes, but we still want them to be reliable. So we have to kind of have a sort of a tolerance. So a test like this would be a step too far, I think. We do have some like this. It's not that they don't exist, but they are notoriously unreliable. So I was just going to summarize what I've talked about. The key thing for me as a software engineer working in the scientific domain is I need a way of capturing the knowledge of the scientists that allows me as a software developer to know if I've done a good job or not. Have I written the software correctly? And there are various ways that we work that help me do that. One is to establish a ubiquitous language of shared terminology that we all agree on the definitions. Collaborating with those non-developers, collaborating with scientists and other people in the organization to try and, to some extent, understand the domain is really, really important. Making sure that we have automated tests on the scientifically meaningful results is really important, because our customers depend on that, and the kinds of things that they're making, medicines and such like, they have to be right, they have to be reliable. And so we have a lot of automated tests that tell us that kind of information. But we also have different styles of test. And one of the good things about a tool like Gherkin is that you can write a test that makes sense to a scientist, but you can also write a test that is much more kind of detailed and lower level than that if you want to, much more precise. And so we can capture different aspects of the problem with different styles of test, and that is typically what we do. So we have validation tests and other kinds of tests that we use as well. So that was it. That was what I wanted to talk about. That was my story of how we use behavior-driven development to work in the scientific domain. I think Michael is going to talk next about some more cloud-based stuff, which will be a bit different than what I've talked about. So Michael, do you want to take it away?
I certainly can do. I do need you to stop sharing now, apparently, to be able to take over the share. There we go. Now my buttons are moved. So yeah, welcome everyone. Thank you for attending as well, particularly taking over, kind of taking your lunchtime and all that other type of stuff to sit here with us and hopefully enjoy some of the content. So yeah, I'm Michael James. I'm the technical lead of the cloud platform. So today's session, I'm just going to really try to keep it short and sweet, which is difficult. This particular topic I've been known to go on for at least an hour, so I'm going to try to get it in 15 minutes for everybody. But it's really about this developer feedback loop when developing in the cloud. So the cloud teams within Waters are relatively new. Chris was talking about all the on-prem products, which have served us so well over years and years and years, and we're now kind of really getting into cloud and kind of cloud native, particularly, not just lift and shift. And one of the things I found when I was working with my teams was this feedback loop, this ability for a developer to make a change, kind of test their change and be able to see, test results, or even if they're using Postman and just poking about the APIs and all that type of stuff, is how can they see whether that's worked or not without necessarily having to build everything, deploy it, all that type of stuff. Okay, so the first thing probably to go through is the problem. What is the problem that I'm calling out? And I'm kind of scoping this to testing the AWS services, but equally this applies to development as well. So, our number one difficulties during testing, basically unit testing, test enough. If you've written lots of unit testing in your time, and I hope you do, you've probably fallen into the trap of unit tests get very, very kind of macro focused. They're very, very small to test in particular bits, and they all seem to run well in isolation, but actually you're ignoring the behavior of maybe the systems you're using under the hood, particularly when we're thinking about data stores or other AWS services, particularly, so message queues, event bridge, all these type of good things. But we then find our end-to-end tests, and this is kind of where we started with a lot of this, which was, kind of deploy everything, use actual AWS resources, run a test suite, that's clicking things, that's poking UIs. The problem is they're slow and they're really expensive to run. When we're trying to use kind of like a graph database, so we use NeptuneDB for the graph, that's something that takes 20 odd minutes to provision. So then that's a really slow test and actually costs quite a lot of money to run. You could, and we have, tried to say, let's have a shared database cluster for everyone to use for their tests. But guess what? You then start getting brittle tests because people are running the same test suites at the same time, and maybe they're not cleaning up their data properly. Maybe they've forgotten to prefix some of that. Basically, it turns into a nightmare. Secondly, these difficulties during development. So we find developers are trying to, message queues is a great example here. We're all trying to develop our services, and then lo and behold, we're getting weird issues happen. It's like, I've just done something and that should have put a message onto the queue and come back to me on my machine. Lo and behold, another developer is running the exact same service and they've forgotten to change their queue name. So they're now using one of your queues or a shared queue, all that type of stuff. And that's frustrating. I've personally been on the end of this saying, why is someone else using my queue when I've already allocated it? And it's hard. And then if you're trying to, develop and create new resources just for you whilst development, great, that works all the time, blah, 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 off we go. But I'm then off for 2 weeks and I totally forget to scale down all my resources. And I've just been running, just cluster and queues and everything for a long period of time. Again, costs money. And it's a bit irritating when someone comes over to you and says, did you mean to leave that really big server running for X amount of time? My bad, sorry. So that's not great. And I've kind of already touched upon it. AWS provisioning can be slow. I've said it is slow, couldn't really to be there as like an example. It does depend on the technology, Lambdas, message queues, they're there available within a minute or so, usually. but it's not seconds, so if you're running tests, particularly in test suites, and I'm going to show some examples, you want your test to be fast and fluid, don't you? Want to click, run test, hopefully within a couple of seconds, you get your result, you move on. If you're having to wait for minutes on your machine, or worse, you've got a variable kind of deployment strategy. So I found this with event bridge rules just a couple of weeks ago, that we found sometimes event bridge rules were created in literally a second or two. Sometimes it was 30 to 40 seconds, which obviously is expected. This is for cloud. You have got latency, you've got other competing resources and people trying to consume them. There is this variance. So when you're developing, it's really hard. It's really hard. So what could be a solution to this? So I've kind of got LocalStack for my development teams, and we've managed to purchase this as a business. I'm not going to promote LocalStack too heavily. I'm not going to go through all its features because there are far better videos online about that. But I wanted to say how we've been able to use this to really improve this feedback loop that I talk about. So as a developer or even an automation engineer, whichever floats your boat really, you can be on your machine, writing code, writing tests, running tests, and getting that feedback really quickly. So LocalStack, just as a brief summary, it emulates AWS. So that's a key thing I put there, is it is emulating AWS. So it mostly is the same, for certain services, particularly the core ones, messaging, event bridge, some of the others, Lambdas, I think, they're pretty much bang on, but they are an emulation. So you've always got to bear that in mind. It is fast on your machine resources. That's what it's providing. So rather than you having to spin up shared resources or run your own Kubernetes cluster somewhere on, in your domain that developers have access to, this is all just running on your machine. So in theory, the better the machine, the faster the resources and tests, in theory. It's there to gain confidence in your changes. So I alluded to earlier that we got to a place where people are writing tests and essentially having to do a deployment to be able to validate whether that change worked or not. Now, for some things that are publicly accessible, like queues or have public HTTP endpoints in AWS, it's not such an issue. But when you're using particularly databases and other data stores that run within a VPC within AWS, they are private. You can't access them from outside of the world without having to fake some way to get to it. So this is why we're trying to gain this confidence. And also, we're using them for integration, not integrated. So I'm not sure if people have heard that before, that terminology, but I call integration tests. So something where you're interfacing with another component. So this could be, we're trying to connect to a data store. We're running some queries, we want to validate these queries, execute as we expect, particularly for like kind of graph database work, writing Gremlin and Tinkerbot queries, particularly. We can have integration tests that are validating that the Gremlin conforms to the Gremlin specification and it matches what we expect. But actually, when we run them against a real Neptune database, which has support for multiple languages, one being Gremlin, one being other types, then actually that's an integrated test because we're using the same resource, the exact same resource we have in staging, in production. So integration is essentially what I call, I'm running it in CI/CD or I'm running it on my machine, and I'm validating that, everything is correct, but it's not using the actual services underneath. That, for myself, is an integrated test. That's so we've integrated services together, not that my service can talk to another service. Okay, so I've got a bit of demo. I do like to get into how this stuff actually works rather than just slides. So just as an kind of an FYI, I'm doing this all pretty much from Visual Studio. This is kind of .NET, very focused. However, and I will say that as however, it is not limited to that. If we've got some teams that are using Python, maybe a bit of Node.js, that type of stuff, they're still able to use LocalStack to improve that feedback loop as they desire. It's just the teams I'm demoing and I've got a little bit more familiarity with is kind of the .NET side. Okay, so here I've got some test results in here. I'm going to actually do a slight callback to what Chris was talking about. So we have behaviors in the same way. Now, we don't just have behaviors. We kind of use these behaviors to provide the spec, which are great, almost the integrated tests that I was talking about. But also we have integration tests where I've just coded them. in XUnit, if I'm honest. That's my framework of choice. So for example, here's a particular feature file. It's using Neptune DB directly, and it's doing a load of stuff that says essentially customer A, yeah, the user for customer A can't see data for customer B, because that'd be really bad. And that's what we've got here. Okay, so normally, I mentioned this is Neptune. Neptune is not accessible from the outside world. It only runs in the VPC. So previously, we've either had to deploy these tests to a cluster, to a Kubernetes cluster that sits within VPC to run the tests, and then get the test results. And, you know, that's like a 20+ minute cycle. You know, you've got to go through your CI/CD system, all that sort of kind of nonsense. Or we've got to poke away, we've got to create a way to connect a dev machine to the VPC. And our pros and cons of doing that approach as well. But the main thing was those clusters are really expensive and they're really slow. So we've either got to have a shared use for somebody, or we've got to be able to allow things to be built up and torn down. Sorry, yeah, I couldn't remember the phrase there. So that's going really well. So then if we look at these tests, and I'm going to run them in the Test Explorer, what we thought was, let's use LocalStack instead. LocalStack provides Neptune equivalent. So what you can do is use your stop and start scripts. So it's Docker essentially. So it all comes through as Docker components. Sorry, I just loaded the wrong file. Here we go. So LocalStack provides everything via Docker containers. Hopefully people are familiar with those. Great way to bundle and deploy, you know, kind of applications and code and that type of stuff. We're using LocalStack Pro because it gives us extra features, which is why we pay for it, but it's still really good. So I've got a Docker Compose file here, and it's just saying I'm spinning up LocalStack, and it's exposing some ports and some other bits of configuration. But the key bit that I really wanted to show you here, and hopefully you can see this and I'll make it even bigger to really make it, is I get to tell LocalStack what services to run. Now, in theory, you could say all, and then wait for a while whilst your computer kind of like handles trying to spin up all its containers. But to keep it fast, keep it fluid, I've said I want a Neptune DB, and actually that depends on RDS. So as a developer, when I'm kind of running this, I just start and stop those containers. So I could do that in the command line. I could say, you know, Docker run, you know, put some ports in, all that type of stuff, to make things much simpler for team members, and to ensure we're using the same configuration in our CI and CD. We've just got a couple of little shell scripts here. So go and start and stop, you know, really keep it simple for maybe some of the newer team members who haven't really maybe touched Docker Compose and got so much familiarity with it. They just want to write some C# code, write some C# tests, click run, and off they go. So that's what I've done here. So if you can see down in my bottom corner here, I've already started LocalStack to hopefully make this a bit quicker. So just switch to my test view, and this is this integration test. This is the behavior, hopefully you can see, and just to highlight how quick it should be if everything is aligning, because live demos are always a little bit on the edge, aren't they? There we go. We can see these tests are running in, you know, about a second or so each, some of them a bit longer than others. Okay. As that's that. Now, I've also talked about how we like to do these for actual kind of C# tests, XUnit tests. So we've got some behaviors, great, you know, that kind of means something to other people in the business, all that type of good stuff. But what about a developer really trying to understand their problem? Okay, so what I was doing was writing some integration tests more from the developer experience. So it's not just for behaviors. I'm really kind of thinking about things that a dev probably wants to get into, wants to handle, that probably don't want to describe in your behaviors. You probably don't want loads of behaviors about retrieve, add, delete. You know, that's kind of really low level details. So we try to do that. Same like throwing exceptions when you try to add duplicate tenants, all that type of stuff. Okay, so where I got to, and hopefully this is relatively apparent for everyone, is I'm running the same integration tests here, kind of XUnit driven, against LocalStack. And when that spins up, I think that's still spinning. There we go. They're going through really quickly. Just to call out some little details of these. Whoop, whoop, whoop. So we're using in XUnit fixtures. Basically, fixtures are a way of saying configure something, and for all the tests to consume. So what we're actually doing here, just really quickly, we're actually creating a database at that time. So I've got a load of like helper code about LocalStack and other bits and pieces. But what we're really doing is making sure on that developer's machine, in that local stack environment, in that local one, we're spinning up the cluster, configuring it as we really expect it to be configured, maybe cleaning up some data, maybe populating it with some data, and then we're tearing it down again at the end of the tests. So this is a lot easier than having to have a shared cluster that everyone's trying to poke and making sure no one's conflicting and stamping over themselves and all that type of good stuff. Great, that's all amazing. But what about when LocalStack maybe doesn't marry up to NeptuneDB in actual AWS? There you still need those type of integration tests, or integrated tests, I should say. So we handle this by using run settings, and I've done some little bits and pieces here. So essentially, I can say at any time in my test, rather than using LocalStack, which is the default, it could use AWS Actual. And I'm just going to double check. I think that lost connection to POV isn't my database one. So what I can do within my test runner, and this is where our demos can really fail, is I can say, using my configure run settings, and I can do this from the CLI as well, from the command line, if that's what you prefer. I can say, use these run settings instead of the default. And then what's going to happen, when I run my tests again, it's actually going to be reaching out to NeptuneDB Actual, a real life NeptuneDB, and I can be hopefully 100% happy that what's been tested against LocalStack runs against AWS. Okay, so we'll see if this connects, because we did have the drop as well. I'm a little bit on the edge of, did my connection drop to Neptune? I might have to recreate it. Just to explain what's going on here as well. We're setting up a proxy essentially. So I've really deployed something, and all our developers have access to this, into one of our Kubernetes clusters, so we can forward traffic from your local machine through the VPC to the actual NeptuneDB. And that's taken a little bit of time, which makes me think that actually, unfortunately, the demagogues have failed me. They've had wrath against me and have said, with all the demo drops and all that other type of good stuff, that I've lost access. So I will give it one last test just so you can see it. So I've got this command dev proxy here. Again, I've just done it for my shell. I can actually authenticate this, which would be grand, which is why I don't normally do it live in the demo. And if it works, great. If it doesn't, I've got more slides. AWS saying, yes, you can do stuff. Great, it's approved. And then what you'll see is basically we've deployed something, kind of using Nginx and a bit of BusyBox and all that good stuff. And it's now going to set up some forwarding rules and allow us to run our tests. So I'll wait for that to say created. Good, 8182 forwarding. So we'll try it one last time. Let's only run one test to give you the real shell of it. And if it works, it works. If it doesn't, it doesn't. I've actually got a longer record. There we go. Look at that. It's worked straight first time that time. So I must have, in between the 12 o'clock start and now, my connection must have been dropped. So there we go. I'm actually running now here against AWS Actual. So I can validate, be really happy, really confident that the changes I'm making have still worked. Okay, that's it for the demo. How are we doing? 12:42. So just to go through the just LocalStack, I've really called it out. It's only an emulation layer. Sometimes things aren't 100%. So in all our testing, we find to get us 90% of the way there, we are developing and testing against LocalStack. We're still using AWS for like once in a while testing on my machine, maybe as part of a pull request, or before we submit the pull request, we might just run it again against an actual AWS environment. We run it in CI/CD as well. We can do that. So we've got lots of options there. So about 90% dev and test, it's quick. It gets us there. There's actually a lot more functionality you can do. You can set up snapshots and you can share them with other developers. So we've got some kind of pre-configured environments in LocalStack and we can share them between devs. So it brings things up to a certain state. Really useful. And then, yeah, we use that final 10% run against actual AWS, when we're running our end-to-end test, for example, which is the UI and then all the systems in between, that 4 systems integration testing, integrated bits, that's all against AWS actual. That, it's about making sure you've got your test pyramids and all those type of things there. So one thing before I drop to my final slide, because I believe people will probably be interested in this, is we're actually then using LocalStack as part of our CI/CD pipelines as well. So we use GitHub and GitHub Actions and all that great stuff. So there's a little bit of waffle in here about our build stats. We do some contract tests run. We'll talk about those another day. We do some builds, we test some, do some parses, all that type of good stuff. So we find within our builds within the environment, we will, again, 90% of the tests will probably run against LocalStack, whereas we might have certain scenarios or certain key critical paths. So we use AWS secrets as well, secrets manager for things. So we're doing most of that against LocalStack. And then we've got one test that will say, I can create a secret, I can retrieve a secret, I can delete the secret, and that runs against AWS actual. So, that's the critical path. So we're doing that. Sorry, build logs, load of great stuff in here. It's essentially spinning up that LocalStack container. Again, it's Docker Compose, and then sets up the network, and then the test container, and can talk to and communicate with the LocalStack container, which is really good. Really good stuff. Right, I know time is short, so I will keep on moving forward. So really for us, this getting the feedback loop right is about the test strategy. Right test, right time. So yes, devs, please write lots of unit tests. Cover all your logic as much as you physically can in unit tests. That's great. When you're reaching out to AWS resources, you probably do need to do some form of integration or integrated tests. We had something where all the unit tests proved that these message attributes on SQS worked properly. Lo and behold, they didn't work properly. As soon as we added LocalStack in, we saw the issue straight away where it wasn't coming back. And we didn't have an end-to-end test for that exact scenario. So actually we had a bug and it was there for several weeks and we never knew about it. So integration tests, great, have several of those, common paths. LocalStack's brilliant for that. And then we've got these few integrated tests, which are, end-to-end, or in some of our instances, running actual, queries against data stores, be that Neptune, Dynamo, whichever your data store of choice is. Okay, and that's it. So apologies for the little drop in the middle. Obviously, we were being challenged by Zoom and all its greatness. But hopefully you kind of got the gist of, how we're developing, why we're developing that way, and how actually in the cloud things are a little bit different. It's not just we own everything, we can deploy everything. We are using managed services and AWS provided services because they're great. But on the flip side, there's a cost to that, and we've got to keep that that developer feedback loop particularly short and sweet. Okay, so again, that's it from me. I'm going to hand over to Nick.
Thanks, Mike. Cheers. Yeah, I'll just try and share my screen now. I've only got one slide very, very quickly, and then we'll hand over to Ellis to run through, I guess, some of the questions and any follow-up or any questions that anybody might have around what Mike and Chris have talked about today. So basically, I wanted to just give you a little bit of an overview away from the technical side in terms of, I guess, our UK side of the business here at Waters, and kind of a little bit about us and what we're all about, really, from that side. I've also put a YouTube video up here that is of our Wilmslow site specifically. So I'll play that shortly whilst just talking you through a little bit about, obviously, both our sites here in the UK and what it is that we tend to, what it is that people tend to do or tend to recruit for within our kind of software engineering side here at Waters. So let me just play this video now. Leave this out of the way first. Okay, so as that's playing through, so we have kind of two main sites in the UK. Our main one is the Wilmslow site, which is an R&D facility not too far from Manchester Airport. So it looks after pretty much all of our mass spectrometry product development, but we also have quite a substantial software development side as well. I think there's about 700 or so people in total in the facility, but as you can see, it's very much a modern sort of engineering and R&D facility, looking after pretty much all of our product development work from that side. We also have a site in Newcastle city centre, which has a little bit more of a focus on software, actually, from that perspective, and probably has between about kind of 25 to 30 people looking after a few of our sort of different software projects as well. And in general, we hire across both locations, across all aspects of software development, really. So front end, back end, full stack development, obviously software development within our cloud, as well as also from a sort of cloud infrastructure and DevOps perspective. And then alongside that, a multitude of different sort of software engineering roles, both within automation and also manual, and then also kind of product owner type roles. So those are the positions that we have currently. And as you can see, we've got a number of the benefits and stuff here at Waters for all of our UK employees. So if you have sort of liked the look of stuff that Chris and Mike have talked about and want to kind of find out more either about what we're doing currently or what type of opportunities we do have, then you can reach me on my email address there. I think there'll also be a recording to this event as well. So yeah, feel free to obviously take another look back through that and yeah, let me know if you have any questions or want to find out any more whatsoever. So I'll hand over to Ellis now. I'll stop sharing and then yeah, I'm sure hopefully everybody's got a number of different questions.
Brilliant. Thank you, Nick, on that one, and also Mike and Chris for your super interesting presentation. So we'll get onto the Q&A section of the webinar. So we've already had some questions come through from the participants registration link. So first one for you, Nick. Any tips for people that have been laid off because of the whole COVID-19 thing and looking to sort of shift careers and entering the tech space? Do you have any tips, any advice for people that are looking to switch careers?
Yeah, I mean, it's a good question. So, I mean, talking from our own experience in terms of obviously people that we've been hiring over the past sort of 2 or 3 years or so, it seems like coding boot camps are a big way at the moment of people getting into tech, and in fact we have hired people yeah, fairly recently with that type of background into various different roles, whether it be within software engineering or software testing or you name it, really. So obviously that is definitely a more popular route. I guess from our perspective as well, because of what we do in terms of the scientific domain, we've also hired people who have maybe come from sort of different types of science backgrounds, so whether it be chemistry, physics, something along those lines, and are maybe looking to take that step into coding as well, and have maybe done some coding in either their own time or have done various different sort of yeah, I guess general kind of training, development, whatever it may be from that perspective, and looking to take that step. And also, yeah, we've been doing a lot in terms of people, I guess, looking to take this first step into software engineering. We had a global internship program this year that we will be looking to carry on into next year, and also an apprentice scheme as well. Again, that's not just specific to software; it can be obviously applicable to other areas. But we have seen, yeah, a number of different people come into our software engineering teams on like apprenticeship basis and stuff like that.
Okay, brilliant. And just touching on that apprentice scheme, Nick, what does that really entail? Is there sort of obviously a lot of it is hands-on, I'm guessing, but is there like a sort of academic side of that as well, or?
Yeah, so we have a couple of sort of providers that we work with that will obviously support them from, as you say, the academic side of things, whilst we will obviously provide the support from the sort of hands-on day-to-day development and general kind of working environment from that perspective. So yeah, it depends obviously on the scheme that somebody comes in at, and also depends on I guess what level that they're coming in at as well. But yeah, we have a couple of providers that we work with that support from a couple of different ways. So some of them may be like a degree apprenticeship for some I guess for example. But yeah, so it depends really on obviously that, but there's different ways that we support from our perspective, and also obviously that they get the external support as well.
Yeah, that sounds great. Okay, cool. So potentially one for Michael and Chris here. Why is developer feedback loop important, and how do you shorten your developer feedback loop?
So I'll start if that's okay. You know, the importance of it is really about, I think personally, reducing friction. You know, kind of making it so a developer can really kind of get on and do, you know, not just a job, which it is, but actually being able to feel part of it, to enjoy it. You know, I'm quite big on developer experience, and you know, when you're kind of developing, and probably quite a few people, not everyone, but quite a few people get into your zone, don't you? And you're kind of solving problems, and it's quite creative in a way. If you hit that friction where you want to find out if something's working or not, and it takes you, you know, 20 minutes, half an hour, you know, or longer, worst case, then that's a source of frustration, because, you know, what are people going to do? There's that great XKCD kind of image, I should have had it ready, where, you know, people are playing in the hallway on chairs and swords and all that type of stuff, pre-COVID, I'm sure. And people say, what are you doing? It's like, build's running. And people will be like, okay, carry on. You know, we're trying to reduce that amount of time that it takes for a developer to know, is this working? You know, is it as I expect? That type of stuff. And even onboarding, you know, we find that developer feedback loop can also be, how long does it take you to take a story? Maybe it's in a new repository you've not used before, clone it to your machine. Can you hit a 5-minute code? And, you know, start running it. If you can't, okay, what's the minimum amount of steps to do it? How can you make sure you're doing your builds the same way as they are in GitHub to get that kind of familiarity? So for me, it's all about making it short and sweet for people to know if their work is correct, really.
That was a perfect answer. I don't disagree with any of that.
Cool, love that, Chris. We've actually got a question come through our live Q&A box. So obviously you potentially touched on this a little bit, Chris, in your presentation already. But what challenges did you face during, or what challenges do you face with BDD, or behavior-driven development?
So for me, I mean, one of the big challenges has definitely been the terminology aspect, because I'm not a scientist. So that process of understanding how to describe the problems, it is quite difficult, but I now get the benefit of it, so I think it's worth the effort. Similar to that, when you're getting started, is it can be difficult to go from nothing on a greenfield project to having the infrastructure in place to have tests like that. You know, the amount of components required to be able to just write some code that looks like a scientist asking a question. It involves a lot of inventing things and a lot of work, so it's kind of got a big like cost to get started. So yeah. I think there's a couple of things that you have to get over to really start getting the benefits of them. So I'm not sure if there's a different way to do it. If there was, I would go for it. But they're to me the biggest challenges. It's like the getting started hurdles can be quite high.
And if I might add to that,
okay, brilliant. And one for Michael here. How long does it take to integrate LocalStack into the development process?
Yeah, okay. The LocalStack, you know, kind of integration, it depends on the size of the teams and your process. You know, my POC that I did, you know, ages ago was, you know, can you use the LocalStack that was free, you know, that free version of it. That's community edition. Get the Docker running. If you're familiar with Docker, particularly, that's quite quick. But I found within a day, and literally one day, I had a POC working, which was I can run something and then I can run some tests and it goes against it. What obviously takes more time and getting it refined is making sure you can add it to, like I was showing, the test run settings, being able to have it as part of our CI/CD pipelines. That takes a lot more investment. But we generally find, you know, it's weeks, not months, to get it integrated. And it depends on where you're starting from. But as long as people in your team are familiar with Docker and Docker Compose, a little bit with the AWS SDK and other bits and pieces, you know, it should be relatively plain sailing for you. I didn't go into it because I didn't want it to be too much of a sales pitch for LocalStack, but they do provide lots of extra utilities. So if you're using .NET, for example, there's some NuGet packages that make it much easier in your tests to switch between, you know, for LocalStack version or a non-LocalStack version. We've also taken it to the end where we use Terraform for our infrastructure as code. We can actually Terraform against the LocalStack provider now to bring up resources. So we're actually kind of for developers saying, run your Terraform against here, that provisions your infrastructure, then run your test against it, which is exactly the same what we do for production against AWS. So yeah, lots of options.
Brilliant. And I'm just looking, obviously, running out of time here. But final question for Nick. Obviously, you've touched on this on your slide as well, but this is obviously from the registration link. How does one get into working with Waters Corporation? What's the best sort of avenue to get in contact with you guys?
Well, I'll probably say reach out to me. But obviously, yeah, I think we've got a careers website where we advertise all of our vacancies on there. So obviously they can apply through positions that they're interested in. As I say, I put my email address on the slide anyway. So people obviously more than welcome to reach out to me. If it's a role that's not in an area that I'm personally looking after, then I can certainly point them in direction of the wider talent acquisition team and the person who is looking after that particular position. So yeah, I'd say they're the kind of two main routes really, alongside kind of everything else that I've mentioned already from that side. Okay,
brilliant. Well, I just want to give a big thank you to Michael, Chris, and Nick for attending the webinar today and presenting and giving us some insight into what goes on at Waters Corporation. Obviously, Waters Corporation, just to sort of echo what Nick was saying, are actively hiring right now. So as a follow-up, we will provide a link to their careers page where you can find a list of their open positions as well as their benefits. If you are interested in career opportunities, please register via the form in the email and we will come back to you. In regards to all of the questions asked on the Q&A, we will answer them and get them back to you. But yeah, I'd just like to say thanks, guys, for joining us on the webinar, and I hope the participants have learned about Waters Corporation today.
Thank you. And thanks, everyone, for joining.